Hey guys, so in today's lesson we're going to do 11-4 standard deviation. So we're going to interpret and compare the standard deviation and spread of data sets regarding the number of assignments two classes have completed. So we're going to look at how spread out they are, how spread out the data is, okay? So, and I know you guys don't know what standard deviation is yet, but you're going to. So, alright. Miss Bean collected data for one of her classes for the number of assignments completed in the first 4 weeks of digital learning. Miss Bean claims that the average amount of assignments completed by students is 4.5. How close is Miss Bean's claim to the data below? So if you look here, okay, there's 20 different students here. One student completed 0 assignments, one student completed 1 assignment, one student completed 2, and it keeps going, okay? So there's 4 students that completed 4 assignments. Okay? So just take in that data. Make sure you copy down this box into your notes. What kind of data display will provide the best view of the data? What do you guys think? Do you guys like dot plots, or do you guys like histograms? Or do you guys like the box plots? So for this type of data, what we're trying to do, the numbers in the data set span a large range. So they go from 0 to 9. They're not really close together, okay? So, to understand the numbers and how they relate to the claimed mean, we need to create a histogram. So I created a histogram for our assignments, okay? So we had 7 students that completed 4 to 5 assignments. We had 4 students that completed 2 to 3 assignments. We had 2 students that completed 0 to 1 assignments. Okay, 5 students that completed 6 to 7 assignments, and 2 students that completed 8 to 9 assignments. So I calculated the mean and the median for this data, and the mean is 4.6 and the median is 4.5. Okay, just know that a histogram is the best when you have a large span of data. Okay. So, what does the data display reveal about the data? Now, I want you to see this shape, okay? This shape here, and I'm going to do it in a different color. The shape of the graph, okay? The data forms a bell-shaped curve. I want to emphasize this data forms a bell-shaped curve. That is important in one of the questions in your questionnaire. Okay? So, the data that is in this shape it's called a normal distribution. Okay? Normal distribution. And again, I want to very much emphasize this is a normal distribution. Okay, so something I kind of want to point out and relate to like what's going on right now is I'm sure on the news and on Facebook and stuff like that you heard about like flattening the curve of the COVID-19 graph. So this is kind of what they're talking about. They want to take that high point, that 7, and kind of like they wanted to like squish it down. Okay, that's what they talked about when they said flattening the curve. Okay. So, just something to relate to, like, real life, because you have seen this shape in real life, especially in today and what we're dealing with today. So, this is really important to actually understanding the news. Okay? So, when data are normally distributed, the most useful measure of the spread is called the standard deviation. Standard deviation. Standard deviation is a measure that shows how data vary or deviate from the mean. Again, standard deviation is a measure that shows how data vary or deviate from the mean. This is a question on your notes. So this is your bell curve, okay? This dotted line right here is your mean, okay? And so we have, you can fall 1 standard deviation away from the data, 2 standard deviations away from the data, or 3 standard deviations from the data. You do not need to know how to calculate standard deviation. That is in a statistics course. But this is, okay, you can fall away from the data, okay? So in a normal distribution, about 68% of the data fall within 1 standard deviation of the mean. So, okay, when it's normally distributed, when we look at class assignments, when we look at test scores, when you look at a lot of things, they do follow this normal distribution. Okay, about 68% of the data will fall within 1 standard deviation of the mean. So most of the data doesn't fall far. Okay, about 95% of the data fall within 2 standard deviations of the mean. So that would be out here in the graph. This is 2. Okay, and about 99.7% of the data fall within standard deviations of the mean. Okay, the most important part here is that about 68% of the data fall within 1 standard deviation of the mean. Standard deviation for the class data is 2.3. Okay, the mean of the data set is 4.6. Okay, students with number of assignments completed between 2.3 and 6.9 lie within 1 standard deviation of the mean. Okay, so to calculate this, okay, we're going to take 4.6 and we're going to subtract the standard deviation, and that gives you the 2.3, okay? And then if you take 4.6 plus 2.3, you get the 6.9. So, to calculate 1 standard deviation away, you just add or you subtract from the actual mean. In a large sample drawn randomly among students, we would expect about 68% of the number of assignments completed to be within 1 standard deviation of the mean, thanks to the predictive power of the normal distribution. Okay, so if things are normally distributed, it's really, really easy to predict things. So like I said, to calculate one standard deviation away, take the mean and add/subtract the standard deviation. And I'm just going to shorten standard deviation to SD. That way I don't have to write it a bunch. So for this example, okay, we took 4.6 and we subtracted 2.3. And that equals 2.3. Then we took 4.6 and we added 2.3. And that equals 6.9. So the range for 1 standard deviation is equal to 6.3 to 2.3 to 6.9. Okay, you are going to have a question about range, and that's what you need to do. You need to add, and you also need to subtract the standard deviation from the mean. Okay. The histograms show the number of assignments completed for 2 classes. The first shows a sample from class A and the second from class B. The red line indicate mean and the green lines indicate standard deviation from the mean. Compare the distributions of the number of assignments completed for 2 classes. Okay, so we're looking at class A. It's the same one. All I did was copy and paste it. Okay, the mean is 4.6. Standard deviation is 2.3. I want you to notice that these are pretty evenly distributed. It's a normal bell curve. Okay, normal bell curve. Class B. Okay, if you look here, the mean is 2.3. It really doesn't fall in the center of the data. Okay. Now, also, if you look how far apart the green line is from the red line. So if you look here, right, it's closer than down here. The standard deviation for class A was 2.3. The standard deviation for class B is 2.7. Okay? This has a higher standard deviation. If the standard deviation is higher, that means the data for class B is more varied. And if the data from class B is more varied, that means it's more volatile. So, let me actually write that down. So, class B has a standard deviation of 2.7 compared to the standard deviation of class A of 2.3. Class B has more varied data. Class B has data that is more volatile because the standard deviation is higher. Okay? Awesome. So class A is more equally distributed. Class B is very varied. It has a lot of varied data. And class B has data that is more volatile because the standard deviation is higher. Okay? For class B, let's calculate 2 standard deviations above the mean. So, to calculate 2 standard deviations above the mean, we're going to take the mean, which was 3.8, and we're going to add the standard deviation twice because we're looking at 2 standard deviations of the mean. So, okay, let me highlight that. So we are 2 standard deviations, so we add the standard deviation twice. Okay? If we take 3.8 plus 2.7 plus 2.7, that equals 9.2. So if a student completed more than 9 assignments, they are 2 standard deviations above the mean. Now, if you wanted to go 2 standard deviations below the mean, you would just subtract it twice. Okay, guys? So, at this point, okay, make sure that you complete the notes questionnaire with the practice problems. I have severely highlighted the questions that you are going to have on the notes. Please watch the video. Do not actually just start taking the questionnaire without watching the video. I know some of you are. Okay. Bye, guys.